Welcome to the NIME workflow named Data4. This workflow uses the customer scores database without missing data to illustrate different options for discretization. We start the workflow by loading the customer scores database, and also in this case we load the customer scores database without missing data. Then we partition the customer scores database in two different partitions, partition A and partition B. In this case we select the configure option and we select the relative percentage equal to 50% for the first partition and obviously 50% for the second partition. Furthermore, we select the Draw Randomly options. We close this window by selecting the Cancel button and we move to the upper branch of the NIME workflow. With the column filter node, we select the day means attribute that will be used to show how the discretization techniques that NIME makes available to us can be used. Then we can start describing which are the different options available in NIME for discretization. In particular, the first one that we present is the node named auto-binner that can be found in the data manipulation column and binning section. This node allows to group numeric data in intervals that are known to be called bins. There are two naming options for the bins and two methods which define the number and the range of values that fall in a given bin. To set up the auto-binner node, we right-click the bottom of the mouse and select the configure option. Then this window opens and first of all we have to select here which attribute must be used for the discretization, so which attributes will undergo the discretization through the auto-binner node. In our case we have just the day means attribute, and in this area of the window we have two different subsections. The first one is the binning method, while the second is the bin naming. The binning method allows us to select which method to use for binning the continuous attribute. In particular, we can select the fixed number of bins. In this case, we make the decision to generate 5 bins. And we can also make the decision about which method to use, if it must be an equal width or an equal frequency method. The second option that is offered is the sample quantize. In this case, we have to specify in this area which are the quantize to be used as split points for the continuous attribute. In this case, we will use the lower quartile, the median, and the upper quartile to generate 4 bins. In the lower section, so in the bin naming convention, we can select 3 different options. We can have the numbered bins. In this case, the bin will be named as bin 1, bin 2, bin 3, and so on. We can select the borders option. In this case, we will have the intervals where each bin is defined with the convention that the intervals are left open, or we can make the decision to select the midpoints option. In this case, the midpoint of each interval of each bin will be used. We can also make the decision to force integer bounds for the binning, and we can also make the decision to replace the target column with the column associated with the discretized attribute. In our case, we select the sample quantize and the bin naming of type numbered. Then we close this window, and once we have executed this auto-binner node, we can access the output again by right-clicking the bottom of the mouse and selecting binnered data. Then the following window opens, and we can compare how for each record we have the original attributes, so they means with the corresponding values for every record of the partition A, and which is here the bin value for the generated variable, which is named day means bin. Then we close this window, and I want to point out that in this workflow we use the quantize auto-binner option, we use the equal with option. In this case we select to use 5 bins, and again we use as a bin naming convention the numbered option. Then we use an equal frequency binning method, again with 5 bins and with numbered bin naming convention. Then we use an equal with binning methods, but in this case we make the decision to use just 3 bins, and obviously we select the equal with option. But in this case, for bin naming, we use the borders convention. Finally, with this last auto-binner node, we use again a fixed number of bins equal to 5. We set this binning processing to be equal frequency, and we select the midpoints option for the bin naming convention. Every execution for all these nodes can be accessed by right-clicking the bottom of the mouse and selecting simply the binning data option. Now it is also relevant to point out something more about this specific information flow. In particular, here we have the auto-binner node, which is useful when we want to apply the result of the binning process to data, to records that have not been used during the binning process. This is the case of binning the records belonging to partition B that was not used for generating the binning, the discretization process. In this case, we will obtain all the data concerning the attribute day means as discretized into bins. In particular, to show how it works, we simply show that here the last column is the column named day means binned, so it is the output of the binning process where we have used the midpoint to represent each bin. Then we can take this column and we can drag and drop close to the day means attribute. So in this case we can, for each record of the partition B, we can show which is the true value of the attribute day means and which is the midpoint value of the corresponding bin associated to it. Then we can close this window and we can move further to describe additional options offered by KNIME for discretizing continuous attribute. One of these options is offered by the numeric binner method. This is extremely flexible and allows the user to select which are the bins that have to be used. In order to show how it works, we select the numeric binner node, we drag and drop it into this area, and we connect the column filter node to the numeric binner node, in particular to the input port of the numeric binner node. At this stage we can open the definition of the numeric binner, and we can select the attribute to be discretized, and then in this area we can add how many beans we want to use. For example, assume we want to use 3 beans. They will be called bin 1, bin 2 and bin 3, and now we can start to define how the beans are organized. So we simply can select the first bin, and at this stage we can specify which are the extreme of each bin interval. So this can be done by simply selecting the values. For example, we can select the second bin ranging from 0 up to 2, and so the third bin will be automatically modified starting from 2 up to infinite. Once we have done, we simply confirm this choice with the OK button, and then we can execute the discretization of the attribute by simply selecting the execute option. Then we can access the output as usual by selecting the bin data option. Okay, so let us now close this workflow by introducing supervised binning methods offered by KNIME. KNIME offers in particular the KIME binner method. KIME binner implements the KIME binning discretization algorithm according to Kogan and Chos of 2004. This is just one possibility of many that can be assessed using, for example, the R nodes. However, in this case, to show how the KIME binner works, we first use on partition A column filter node, which is devoted to remove all the qualitative attributes. So we will discretize all the quantitative attributes. Then we use the KIME binner node, and we set up this node by selecting configure and by first specifying which will be the attribute to be used for the supervised discretization. In our case, we select the churn attribute, which is the class attribute. Then we can also make the decision whether to sort in memory or not. Once we have done with this setting, we simply close this node and we execute the node. So the output of the execution can be assessed using the view binning model. This window opens, and we can check which is the output of the discretization, of the supervised discretization implied by the KIME method. In particular, here we have all the quantitative attributes, and we can also scroll the additional quantitative attributes. And here we have the minimum value and the maximum value of the considered attribute, in this case of the attribute account length. And here it is located the split points that has been obtained with the KIME algorithm. So for each attribute we will have the split point, the corresponding split point that splits the interval of the values of the attribute in two different bins. We now close this window and we close this workflow by telling something about the KIME applier. And the KIME applier is exactly the same as the auto binner apply that we already presented and described before, and it is used to apply what has been developed with the KIME binner on a new dataset, so on those records that were not used to build the KIME binner. And also in this case we can access the output of the execution of the KIME binner apply by selecting the option bin data. In this case, we made the decision to bin all the quantitative attributes, and so this is the result we get, where all the original attributes have been replaced by their discretized counterpart.